Welcome to this video tutorial of CohortExplorer. In this tutorial I will show you how to query entity attribute value repositories such as Opal and REDCap using an abstracted search interface provided by CohortExplorer. First of all, we will download the package from the metacpan website. We search for metacpan CohortExplorer in Google. And click on the first link. The first link generally is the most recent version of CohortExplorer. We download the package by clicking on the download link on the bottom left of the web page. We uncompress the package and navigate to the Debian folder. The Debian package can be easily installed by invoking dpkg or gdebi. The package is basically written for group use, so it is the systems administrator or the data manager who is expected to set this up for your group. The administrator can install this package on a machine, and the users can log into this machine and run CohortExplorer. After the installation, the administrator can configure the data sources by following the instructions in the data source configuration file present under etc. CohortExplorer directory. Let's look at a sample data source configuration file. At present, the tool provides the APIs for Opal and REDCap, so we can easily configure the data sources implemented under the software here. The parameters needed to configure Opal data sources are type, that is data source type, by default standard or cross-sectional, entity type, by default participant, Opal URL, database DSN, username and password. If the data source is longitudinal, the ID visit separator and static tables can be provided. The name of the data source is the column name in the table data source. To configure REDCap data sources, we only need the database DSN username and password. The inbuilt REDCap API will set the remaining configuration specific parameters. The data source name, in this case, is the column project name in the table REDCap projects. The connection to the database is expected to be read-only. For example, in the first block, we configure the data source ANMDCR, which is implemented in Opal running under MySQL environment and contains the data on Alzheimer's and dementia cohort. The data source is longitudinal, and questionnaires, demographics and family history are defined as static tables. That is, the data on these forms is only collected once. Similarly, the next block carries the configuration for bioresource data source implemented in REDCap. The namespace parameter in both the blocks contain the full package name of the inbuilt API, which the application will use to consult the parent EAV schema. For security reasons, the contents of this file are only accessible to the systems administrator. We open a new terminal. Type CohortExplorer and press Enter. We see a list of options the tool expects. Having configured the data sources, we can move to query in these data sources. To run CohortExplorer for Opal, the user must have the permission to view values of at least one variable from at least one base table. By base tables, we mean the tables excluding views. For example, to run CohortExplorer for the ANMDCR data source in console mode, we type the following. The username and password we provide here is the same as our Opal username and password. We can see the application initializing. We can see all 6 commands. To run a help command, we simply type help or simply H. To get help on some command, we type help and press tab. We see all 6 commands as suggestions. Let's get help on the describe command. We see describe command prints the data source description, including the entity count. To run describe, we just type D or describe. We see a tabular output. The header of the output shows ANM DCR data source contains data on 1,449 entities or participants. The data source has 24 tables or forms, all collecting the participant data. The label associated with each form can be seen under the description column. To explore what variables are present within this data source, we can run the find command. So if we simply type help find, we see the command can help us find variables by providing the keywords. We can make our search case insensitive and fuzzy. By default, the keywords are joined as OR. That is, the command assumes we are interested in variables containing either of the keywords in their variable attributes. We can override this setting by specifying the AND option. We type find and press the tab key. We see some suggestions. These suggestions, as you may recall, are the table names. The command assumes the user is interested in the variable dictionary of some table. Now if we type a hyphen and press tab, we see the suggestions are different. The suggestions are basically the name of the options the find command accepts. The tool, when running under the console mode, offers a helpful tab completion, where the attention is paid to the user's input. Let's do a case insensitive and fuzzy search to find all variables that are associated with cancer or diabetes. We type the following command and press enter. We see a tabular output with variable dictionary. The command looked for the keywords cancer and diabetes in all variable attributes, and finally returned these 3 variables meeting our search criteria. For example, the first variable is past history 7, recorded under the CAMDEX table. The variable is of type text with no unit. The variable is a categorical variable with 3 categories: yes, no, and do not know. The variable is of type text, so no validation is shown. The value of the variable is the answer to the question, has he or she ever been diagnosed with cancer? We can see the first 2 variables contain the term cancer and the last one diabetes. This was a simple OR case where we were interested in finding variables containing either of the keywords. If we are interested in finding variables that contain all keywords, we can run the find command with the AND option. We run a find command to see if there are any variables that contain the keywords MMSE and total at least in one of their attributes. The find command has returned 2 variables which meet our search criteria. We can see the first variable is a categorical variable with two categories separated by a new line. The second variable, MMSE total, is an integer variable with values ranging from 0 to 30. Having found our variables of interest, we can search for entities or participants that meet some set criteria. For this we have two available commands, search and compare. Let's run a help on search command, followed by help on compare. We type help search. In search command, we can provide the output directory using the out option, export some table by using the export option, export all tables using the export all option, stats option to show the descriptive statistics, and save command option to save the command. Using the condition option, we can also impose conditions on the variables using all valid SQL operators. Let's run a search command to see the disease status for all participants who have scored between 12 and 25 in their mini mental state examination, also called MMSE, in their first 3 visits. We type search followed by hyphen and press tab. The suggestions in this case are option names. We first choose the out option and press tab. We see the output directory is auto-completed. We specify the stats and save command option. And next we impose a condition on the visit using the cond option. We type cond visit and press tab. The condition has been auto-completed, and now we only need to specify the operator and the value. Because we are looking at the first 3 visits, so the operator is less than and the value is 4. Next we apply the condition on MMSE total. Finally, we can supply the arguments or variables. To see all the variable names, we press tab, and the search command suggests all possible variables the user has access to. We choose some variables, like the participant's sex present under the demographics table, and the disease status present under the conclusion table. We run the command. We see a tabular output for descriptive statistics. The first column is the visit column. Because MMSE total is a numeric variable, we see mean, median, standard deviation, etc. Whereas for categorical variable like disease status, we see the frequency and the percentage breakdown by each category. The number of observations, that is capital N, in each variable is the number of times the variable was recorded at the visit given by the first column. If we go to the output directory, we can see the files CohortExplorer has written as part of the search command. We see 3 files: query parameters, showing the parameters we specified as part of the command, query output CSV actually contains the data, and summary statistics CSV is the summary statistics file. Let's open the file query output and look into it. We can see that the first column is the entity ID, second is the visit number, and finally all variables in the query set. This file can be easily parsed by the statistical software like R for downstream analyses. We can see that in this file the entities are repeated along the rows, and it is the entity visit combination which makes a given row unique. Next, we run a history command with show option to see our command history. We see the command we just ran. If we want to rerun this command, we can simply copy and paste it. We can add or subtract options or arguments depending on our requirement and run the command. Now we can see the functioning of the compare command. Let's get help on the compare command. We type help compare. We see the compare command takes the same options as the search command. The compare command is only available to longitudinal data sources. Using this command we can specify a condition at the visit level. For example, we can run this command to get a list of the participants who previously had mild cognitive impairment but now have Alzheimer's disease. To answer this question, we need to compare the participant's disease status between the first and the last visit. The last visit can differ from one participant to another because the number of times the participants were interviewed may vary for different participants. But in the compare command, we can easily impose conditions by using the suffix vLast. Let's look at this case. We can see the descriptive statistics. The statistics in this command, as we can see, are computed with respect to the entity ID, and the number of observations for each variable is the number of times or visits each variable was recorded for each entity. Let's go to the export directory and see the exported data. Again we can see the file, query parameters, query output and summary statistics. Let's open query output. Here we can see that the first column is the entity ID, followed by the first visit number, last visit number, all visits completed so far, and finally the query variables. We can see the variable vLast is different for different participants. We can also see that unlike the search command, each row in this file is uniquely identified by the entity ID. I will now exit this application and run Cohort Explorer for the bioresource repository implemented using REDCap. In order to use Cohort Explorer with REDCap, the user is expected to have the permission to export data in REDCap. The application pays attention to REDCap permission appertaining to the inclusion and exclusion of records and variables. Let's run the describe command to get data source description. We see that the data source is comprised of 4 tables or forms and contains data on 1062 entities or participants. We can also see the number of variables present under each table along with the ARM name, table label, event count, that is the number of times the form is used for each participant throughout the study, and the event description with day offset shown in parentheses. If you are familiar with REDCap, you may know that REDCap uses the concept of day offset, that is the occurrence of an event in days since the baseline. We can see that in this data source the visit is the only dynamic table because of its repeated use to collect data for the participants. Let's run a find command to see what variables are present inside the visit table. The variable dictionary in this case includes variable name, table name, type, unit, category and the associated label. The category information is spread across multiple lines. The category's value and the label are separated by a comma. The value of a category can be text or a number. The user is expected to pay attention to this feature when imposing conditions on the categorical variables. Having seen the variable dictionary, we can run some entity search specific commands. The search and compare commands can be run exactly the same way as previously. Let's run a search command to see the participants who have donated blood between February and April this year of 2014. Because we specified the stats option, we see the descriptive statistics. If we are interested in knowing the participants that have donated blood in all visits, we can use compare command. In this case we don't need any prefix such as V1, V2, VAny or VLast, as we are interested in all visits. We type the following command. We can see the results are exported to our export directory. We can also run our commands on the standard shell. To demonstrate this, I will copy the command and paste on the shell. This feature of the application can be used with the Chrome daemon to schedule reports. I hope this tutorial has given you an idea of how you can query the data sources stored in different EAV repositories using an abstracted interface. At present, the application comes with inbuilt APIs for querying the Opal and REDCap data sources. In the future, the application will be available with APIs for other electronic data capture and management software such as OpenClinica, LabKey and I2B2. Thank you for watching.